if you looked at this stuff and it looked really odd, like we had multiple folders for the same things or multiple grades or something like that, it's because I accidentally imported last semester's structure onto this one. And I've tried to clean it up and delete everything, but if you're seeing anything weird, I need to view it in student mode, make sure I cleaned it all up. So our PowerPoints for Unit 2, we're starting with 5. Why is it showing Chapter 4 as part of? Alright. Why does it have two different chapter names? I'm going to go with the I one. Alright, using pre-built methods. We haven't done much with methods. We may have brushed upon them very briefly. We certainly haven't written very many of our own. We may have done one or two in class. I do not recall that being the case. A method in this language is what you call a function in Python and in C++, although both of those also support methods as well. And a method is a function that is attached to a class, to an object. And we've been using some methods already. We've been using nextInt, nextLine, nextDouble. Those are all methods. They're all part of the string class. So the API library. API stands for Application Programming Interface. If you're writing a complex program, you're probably going to divvy it up into pieces, and then if you're going to give that to somebody else to program, or you're making it large enough that you need help in organizing it, you organize it and you break it up into classes, and then those classes will have methods. Then you document those methods, and that becomes the application programming interface. And you could give that to somebody else, and they could write a new program using your classes. And the same is true of Java in general. It comes chock full of classes, you know, hundreds upon hundreds of classes that the inventors of Java have added. And Java is like on version 8, and it's got lots and lots and lots of classes built in, and we're only going to brush upon them. So, when working on a programming problem, you should check to see if there are pre-built classes that meet your program's needs. So when I took programming in the 80s at a university, and we wanted to write stuff that manipulated arrays so that you could insert items into the middle of an array, or count the number of items in an array, or sum them all up, you would write your own code to do that. Nowadays, libraries are invented that'll do all that kind of stuff, or at least a goodly proportion of them. So you can often find libraries that do what you're trying to do and use those and save 90% of your programming time. If you had to write every function, every class, every object that would run a Windows-based program, with buttons and stuff like that, it just takes you a long, long time in order to do that. And like the difference between Windows 3 programs and the programs that we use now. I don't even know if any of y'all got to use anything as old as Windows 3. But there weren't libraries to generate the applications. So the only people who could make really complicated applications were people who had hundreds of programmers, like Lotus or Microsoft. So if there are such pre-built classes, use those classes. Don't reinvent the wheel. Math calculations, for example, are rather calculated. You don't want to write the code to perform a sine function. You could. All of those math functions are, based upon simpler math operations. But you don't want to write those. You don't want to write your own trigonometry functions. So you have a math class. The math class handles those calculations. If you need the sine value of something that is 2 radians, which I don't remember how many degrees that is, or if you need to convert radians to degrees and back. The trigonometry functions in the math library, by the way, depend upon radians. And so if you want to figure out what the sine of 90 degrees is, you have to convert from 90 degrees to the number of radians. And if you're going, holy gosh, I don't remember, all this stuff from trig, well, I'm not going to give you any problems that require that, most likely. So Java gives you a whole bunch of classes, commonly known as the application programming interface. They're not part of the core language, though. There's a core language, which is just all those keywords and the syntax. But then anything you have to add an import to the top of the code in order to use, like the scanner, is an extension to the language. And why do they do that? Because you may write code that doesn't need a scanner. And you're writing code, Java code to run a set-top cable box or whatever. And that's what it was originally designed to do, is run code for appliances. You're not going to be typing stuff in on a keyboard on your microwave, so you don't need a scanner class. So you use the import statement, and you specify the class, but not only the class, you specify the package. Java.util is the package. And we've been having package statements in our code as well. It's just a subdirectory that it's stored in effect. And we've been removing the package statement, I believe, in a lot of our code. So a package is a group of classes. Most of our packages have just been one class, but they could be a lot of classes. You could, keep doing file new and keep adding classes to your package if you wanted to. Java.util already gives you a whole bunch of general purpose utility classes. We've been using the scanner class. Let's take a look at some others. I'm going to do just java.util. It should take me to Oracle's website. By the way, the answer to the who invented it was Sun, not Microsoft. Sun no longer exists because Oracle ate them. But anyways, lots of classes in the java.util. We'll get to use some more of these, but not nearly all of them. Random is fun, so that we can generate random numbers, like die rolls. Collections are cool, so you can use array list rather than arrays once we start doing that. In fact, there's an array class. Anyways, so if you go out to the documentation, on Oracle's website, you can click on a specific one of those classes and learn more about it. Like the scanner, you could go down and find a list of all the methods that are in the scanner. And there we go. It shows us all sorts of stuff about how to use it. So far, the scanner class may be the only package that we've been using. I could be wrong about that if we've already used a random number generator. I don't remember doing so. Some classes are considered so important that Java automatically imports them for you. Those are the classes that are inside java.lang. So you just get those for free. You don't have to add an import for them. So let's just look up java.lang and see what methods, what classes are in it. Boolean, byte, character, double, integer. These are all with capital letters though. Not lowercase. String. We've been using a string class. That may be about it. The math class. So we don't have to import math before we start using it to calculate trigonometry and power of and stuff like that. If you want to, you can import a whole bunch of classes at the same time with the asterisk. If we did java.util.star, we get all of the classes that are inside the java.util package, including the scanner, called a wildcard. If you're a command line or a terminal junkie, you're familiar with that idea. You type dir star.txt, you get a list of all the txt files in your directory, or in Linux or whatever, it's ls. Star.txt. The star is called a wildcard. Works in our import statements as well. So to use an API, you don't need to know the internals. You don't need to know how the scanner works. The scanner class may involve a whole bunch of stuff written in assembly for all we know. We don't need to know how it works. We need to know what it does and how to call it. So to use a method, you need to know what type of arguments to pass into it. Arguments are the things inside the parentheses, like the print function. You know, system.out.println. We pass stuff inside the parentheses. Those are called arguments. The standard way to show the information is to show the method's source code heading. For example, if we see this, public int nextInt, this tells us, just looking at it, that this thing doesn't accept any arguments. There's nothing to pass into it, but it does return an int value that you would then store into your own int. So just like int days is equal to stdin.nextInt. And I always just use sc for scanner. It's easier to type than stdin, but the book always uses stdin. All the methods in the API library are public, which means they're accessible everywhere. There's another keyword called private, which we will wind up using, but that just means that they're only available to that package. And why would they give us methods that weren't available to us? So they're all declared as public. So the math class includes functions like ABS for the absolute value, MAX for the maximum value. All right, guys, did I ask test questions over ABS and max? No. Okay, good. I did in another class, and then I got my circuits twisted and I thought, uh-oh, I was asking them before we introduced them. That was Python and scripting. So this tells us lots of information about it. That you can pass in two numbers into max. These are the parameters that accept arguments. So we have to pass in two arguments into max, and that returns an int, unless you pass in doubles, in which case it'll return a double. And then static implies something else. Static means that you don't have to create an object in order to use it. Now, we've been creating objects all along, but only of one particular type, the scanner. We've been doing this, up at the top of our code, import Java, .util.scanner. And then later on inside main blah, 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 we've been doing this. Scanner, sc is equal to new scanner, like this. System.in, right? Looks like that. That's our main method declaration. Now, this is what's known as creating an object. We use the new keyword. We have a new scanner to play with. We could create hundreds of scanners if we want to. The methods inside the scanner you call like this. Int x is equal to sc.nextInt. But there are other methods that don't require you to create the object before you use it. It would be really annoying if every time we wanted to take something to the power of, we had to do this. Math m is equal to new math. All right, now I got an object, and so I can finally say, double x is equal to m.pow, 3 to the power of 13, whatever. It'd be annoying if every time you wanted to do some math, you had to create a math object. So instead they made it in a special way, so all you have to do is say double x is equal to math.pow, like that. If your if your method is prefaced, if the variable is lowercase in front of it, that means it's not a class, it's a variable, it's an object. And you are using what are known as instance methods. Instance methods are methods that are attached to each individual object. If the thing in front of the method name is capitalized, that means it's a class. So this is a class method. Class methods are defined as static, meaning you don't have to create an object of that class before you use it. And our main method is declared as static. Why? So the Java virtual machine doesn't have to create an object before it runs your application. It can just call, filename.main, and it's off to the races. Why did I talk about that? Because this slide shows static. This implies something about ABS and Max. It implies that you don't have to create a new object in order to use them. You can just call them based on the name of the class. If I want to use the absolute value function, I just do math.abs or math.max or math.pi. And you're going to hit static again and again and again. You don't have to get it 100% right now. So the math class, there are functions: min, max, POW, round, square root. Let's just play with a few of those. So, new project, if you're using NetBeans. By the way, I don't know if you can see up here, but this thing before the period in the main class is actually the package. You could delete all of that before the period and including the period, and it wouldn't add the package statement to your code. So I'm going to do that. I'm going to delete that lowercase Java application 21. And then my class name itself is going to be October 10. I'm still stuck in September. Alrighty, so October 10, and click Finish. The project name I could call October 10 as well. And if you don't delete the package in there, whoops, it added it again anyways. My fault. Once I changed the name of the application, of the project, it added the package declaration back in. So I'm deleting it again. I deleted it, clicked on it, did change to correct folder, move to correct folder. I always like to have our name, our class, October 10, demoing math functions, chapter 5. All right, let's take a number and send it through some permutations. Double num is equal to 1. One is a boring number though, because you squared, it's still 1. You take the square root of it, it's still 1. So let's change it to 10. So let's get the square root of it. Num is equal to math.sqrt. Num. And as a matter of fact, let's declare a new variable for that. Double sqrt is equal to math.sqrt of num. Now let's take it to the power of something. Maybe we're just going to cube it. So double cube is equal to math.pow, that number, comma, 3. Now int min is equal to the minimum math.min of 3 comma negative 3. Int max is equal to math.max 3 comma negative 3. Now we've calculated 4 values. Let's get the sine and the cosine, or at least the sine of, I do not remember how to convert radians. 2 radians, 90 degrees in radians. 1.5078. Alrighty. So let's get the tangent of that. Int, no, it's going to be a floating point. Double tan is equal to math dot tan 1.5708. That's 90 degrees expressed in radians, according to Google. Let's print some of these out. System.out.println num equals end quote comma num. System.out.println sqrt equals end quote comma sqrt. I've got a syntax there on each of these so far. Oh, because I'm not doing Python or C#, I am doing Java. I need to separate these with plus signs. So go back into your print line and change your commas to plus signs. And then if you get tired of typing system.out.println like I am, just copy that line, paste it, and then you can change these pretty things pretty quick. Cube, cube, min, min, max, max, and a tangent. And I may have done this more quickly than you, especially if you did not copy and paste and edit. I'm going to go ahead and run it and make sure it works for me. Alrighty, that tangent is looking awfully weird. Is tangent actually accepting a 90 degrees rather than radiant? Yeah, it's radians. Okay. I must not really know how. Oh, 90 degrees. Pardon me?
Do math.pi over 2.
Well, no, you're right. It's because it's 90 degrees.
Yeah, it's because it's 90 degrees, but let's do math dot pi over 2. I should have done 45 degrees. Alrighty, I'm still confusing myself. So, 45 degrees in radians. Flub this example. 0.785. Okay. So, if this doesn't give me a value I like, I'm just stopping here. Instead of math.pi, it's going to be 0.475. That looks good to me. I should have done sine or cosine rather than tangent, because tangent is rise over run. And if it's 90 degrees, the run is 0, right? So if you pass in 0 as, or excuse me, if I had done radians exactly, and I'm not sure why I hadn't done radians exactly, it should not have returned that small number. By my recollection, it should have returned 0. Okay, we're talking too much trigonometry. Let's be done with that. So that's the math library. Should call it the library, the math class, which is inside java.lang. If we had to add an import for it, which we don't, we would add import java.lang.math. Fortunately, we don't have to. Just like for string, we could import java.lang.string, but there's absolutely no reason to. But it means that it's in the java.lang package, and that's the class name. We didn't use absolute value, but y'all know what absolute value is. Absolute value just takes a magnitude, meaning it drops in negative if there's a minus sign in front of it. So the absolute value of negative 10 is 10. Oh, and random. I don't use the math class's random number generator because you have to manipulate that number consistently to get a good value. Not consistently. And yeah, you always have to manipulate the value of the math.random method in order to use it. And what do I mean? Because it returns a value between 0 and 1, but not including 1. So up to, but not including 1. Okay, great. I got a random value between 0 and 1. You know, so it could be 0.43, and then you call it again, and it's 0.982, and stuff like that. Then if you decide that you were trying to generate a die roll, which is between 1 and 6, you have to massage that value. I don't like massaging the random number value, so there's a random number class, which we would want to use. And let's go ahead and use it just for fun. Let's go back to our code. And I don't recall if the random class is built in or not. I don't think it is. I think it's part of java.util. Yep, it doesn't know what it is. So I'm going to scroll up to the top. And you don't need those two import statements that I have there, but you do need this one. Import java.util.random. Or better yet, import java.util.asterisk so that we get the scanner and everything else. But I'm going to leave the random one there. Well, completely unnecessary to have both of them.
What does the asterisk do again? Is that?
Brings in all the classes.
Oh, cool.
So not just random, but the scanner and everything else in there. I don't recall being able to do that in any fashion inside Python, but you can do import star from class. But that's a little bit more specific. Alrighty, so let's make a new random object. Random space lowercase r&d is equal to new random. And we have talked about for loops, have we not? Let's print out 10 random numbers in a row. For int I is equal to 0, I is less than 10, I plus plus. Let's make a random number. Int num is equal to rnd.next int, and we need to pass in our upper parameter. Num is already defined, excuse me. Okay, rand num, or rnum. Rnum is equal to random.nextInt. See, nextInt takes two different possible values, or two possible arguments. One argument is absolutely no argument, and then the other is an upper bound. And I don't recall if it's inclusive or exclusive. So I'm going to view the Java doc for it. I'm going to do window. Nope, I'm going to right click on it and do show Java doc. And it tells me that nextInt can take a bound and the upper value is exclusive, meaning it doesn't hit that number. So if I want to generate a random number and I put a 6 here, it's only going to generate numbers 0 through 5. Which actually is going to be adequate for our purpose. You just have to remember that this number is up to but not including. So it starts at 0 and it goes to 5. So we're going to get numbers 0, 1, 2, 3, 4, or 5 each time. Now let's print out our values. System.out.println. Let's print out I plus a space plus rnum. Just so we see some numbers in front of them. So it'll count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alrighty, so here are my die rolls. Well, not quite, because they never hit 5, and most of my dice don't have a 0 on them. Unless you're a Pathfinder or D&D player, in which case you may have dice with 0s on them. Percentile dice, you have 2 dice with the numbers 0 through 9 on them so that you can roll them and generate percentiles between 0 and 99. But anyways, what am I going to do to this so that instead of it being 0 to 5, it's going to be 1 to 6 like a regular cube die? I could just add something to it that's going to change 0 to 5 to 1 to 6. Come on, I know that half of y'all know what it is. Add 1 to it. Okay, so what I'm going to do is say rnd.nextInt 6 plus 1. If I wanted a number between 1 and 10, I'd make it nextInt 10 in parentheses plus 1. And there we go. There's our random dice. We rolled it 10 times. We got a 2, a 4, a 1, a 4, a 5, a 6, a 3, and a couple more 1s and a 3. We could be adding those numbers together so that we figure out what the average is at the end of it. So to add numbers together, you need to declare an accumulator, like total, up at the top. So before my for loop, int total is equal to 0. Every time I get a random number, I'm going to add it to total. So underneath that print statement inside my loop, total plus equals rnum. Now let's calculate the average underneath it. I should not have made total an int. I don't want it to do integer division. I don't want it to say that the total of it, you know, if it rolled out all these numbers together and it got 21, and then we divide by 6 or something like that. I don't want it to round it down. So total should be a double. Anytime I'm accumulating totals or calculating averages, if I remember, I'm going to use a double. Now let's get the average. Double average is equal to the total divided by the number of rolls we made, which in this case was 10. Then we can print those out. System.out.println total equals plus total. And then system.out.println average equals, end quote, plus average. Now something's nagging at me. You see that 10 there? I hate hard coding numbers. I would prefer to make that a constant. So I'm going to declare a constant. And the singular of dice, although it sounds funny, is die. So I'm going to declare a constant that's going to say final int die underscore rolls equals 10. So I added that above my for loop so that I can then cut that, copy it, and everywhere I had 10 before, I can replace it. So both in my for header and then in my average, I've replaced those 10s with constants. Why? Because we may wind up using that 10 a lot. And then later on, somebody may decide that they really wish that we had only done 5 die rolls because they're programming Yahtzee or something. And then they could change it into change it in one place. And you see that 6 there? That should also be a constant. Maybe. Because You may not just be rolling 6-sided dice. You may be rolling polyhedral dice for Dungeons and Dragons, 20-siders or whatever. So, but anyways, that's good enough. I don't want to make it look overly messy. I do want you to see how to generate random numbers, because random numbers are cool. They make programming assignments more interesting. Like, pick a random number between 1 and 100. It'd be really boring if the computer just told you, it was 45 every single time. Everybody got this working? If not, I'll come back and help. I don't see any waving hands, so I'm going to assume y'all are doing okay. Notice that some of these methods have two versions. There's a version of min that takes integers, and there's a version of min that takes doubles. Well, how does that work? How do we write one function that accepts different types? Well, that's called overloading. And overloading sounds bad, like, oh, I've overloaded it, it's going to break. In this context, overloading a method is just providing a method with different parameter lists. You can write a method that takes an int, and another one that takes a double, and another one that takes a string. And that way, you can pass any kind of data, as long as it matches those, to it. They could have just written this one, the one that accepts doubles, rather than the ints, because ints get converted to doubles when you invoke a method just fine. But then it would have returned a double. And if you're comparing two ints, you probably wish that it would return an int. So that's why they give you two different versions of it. So the static modifier on the header of each math method makes them static methods, which are also known as class methods. And those are the methods where you can just use the class name. Math.abs. Write a Java statement that updates x's value so x gets the absolute value of its original value. Alright, sure, why not? Let's go into our code, and you do that. Declare x is equal to -10, and then write a function, a method call that calls math.abs that gets the absolute value of x. It stores it back into x. I'll give y'all 20 or 30 seconds to type it, and then I'll type it myself. Alrighty. So x is equal to what? I just heard like 80 y'all type it in, so tell me. X is equal to, come on guys, math.abs x. Y'all are being mean by not giving me the answers. Good enough. If I ask that question on a quiz or whatever, I'm absolutely sure you'd be able to do it.
What does they give you the little warning saying that the assigned value is never used?
That is true. We never use it after this point. Now that sure is being picky of it. But we never print it out. We never pass it to anything else. So it's true enough. Now when we're typing in this demo code, it doesn't really matter that an initialized value or the assigned value is never used, because I just really wanted you to see how to call it. To me, the more annoying one is this. What if I don't type this, but int a is equal to 0, and then I type int b is equal to 0, and then later on I say a is equal to, math.min of a or b, whatever. No, that didn't give it to me. What if I later say a is equal to 31 for some reason, and I do a calculation based on it? Oh, fine, don't give me the error. Notice it underlines them, though. It says variable A is not used. Well, that's true. Other times it'll warn you and say this initialized value is not used. And I'm actually not getting that warning right now. But it drives me up the wall because when I define my variables, I'd kind of like to be able to set them all to 0 as I did it. Even if I didn't use that 0 later, even if I just overrode it. That's just maybe a personal quirk. But I wish it didn't give me a warning. Oh, there it came up now. No way. Sorry, my mistake. Anyways, if you want, look at those errors and decide those warnings and decide whether it's something you don't care about. And in this case, the fact that we didn't do anything with X, so the assigned value is never used, I don't care about. We could print it out and that error would go away. Disappointed the other one didn't come up. You'll see it eventually, I'm sure. But assigned value never used just because you initialized it to 0 bugs me. Why does it bug me? Because until you initialize a variable, it doesn't have a value at all. And so later on, if you try to print it out or something, it'll tell you that you can't print it out. And I wish that it had a default value of 0, so it'd be okay to print it out even before I've given it, a different value. Whatever. It is legal to pass an integer value to a method that takes floating points. So for example, if we come back up here, POW, or round, only takes doubles. But if we passed an int to it, it would just convert that int to a double on the fly and not care. A better example would be POW, because why would you round an integer? It's already rounded. If you call POW and you pass in 2 ints because you want to take 2 to the power of 2, you pass an int there and an int there, but inside the code, it converts those ints to doubles, so that by the time you're inside that function, which we're not, but it'll process them as though they were doubles. It does the conversion on the fly. The reverse does not happen. You cannot write a function that takes an int and then hope that it'll accept doubles as well. If you wanted to accept doubles, you'd have to write a separate version of that function, of that method. I need to remove the word function from my vocabulary for this class, but in my Python classes and C++, it is still a valid term to use. There are no functions in Java. Everything is a method, because in Java, everything is a class. It's an object, except for primitive values like int and float. Boy. So there are wrapper classes, not like MC Hammer. Wrapper class is one that extends the ability of the primitive data types, int, long, float, double, and char, or character. The most common reason you use a wrapper class is if you want to parse a string to turn it into that number. I'll give you an example of that. If I had a string containing a number, string s is equal to, 1, 2, 3, and I wanted to put that into an int, here's what I cannot do. Int I is equal to s. Nope, that doesn't work. Because as far as the computer is concerned, characters are completely different from numbers. This is stored as a series of Unicode values, not as an int.
If it was in a list, could you switch them back and forth, or is it still
I'm sorry, pardon me?
If it was in a list, could you switch them, or not?
You could even switch on a string in this version of Java. You could not on earlier versions. I don't know if I'm answering your question or not. So, what I need to do, you're right, I could do that. I could build a switch on the string, but, I don't want to write a million different switches in order to build each one. Instead, I want to, quote, parse it. Now, in Python, it's as easy as this. I just say, okay, I is equal to the integer version of s. That sure would be useful. We don't have that luxury. We got to do this. I is equal to integer dot parse int, and then pass that string in, like that. That'll turn that string into an integer. Suppose we also wanted to turn it into a double. Double D is equal to double dot parse double, parentheses s. Yes, sir.
Is there any way to have a string that's like 1 plus 2?
If you need to, that's not only parsing it, but it's evaluating it. Let's look up and see if there are libraries available. Evaluate arithmetic expressions in Java. And my hunch is that there's not. Evaluate mathematical expressions quickly and accurately. Well. No.
Okay.
There's no easy way. That doesn't mean you can't find a library for doing it. I'm sure somebody has written libraries that'll do it for you. I'm just not seeing a library that Java provides, which is kind of too bad. I think that'd be very useful to have. Evaluating a math expression given in string form. Let's check Stack Overflow. They're smarter than IBM. Here we go. I'm trying to write a Java routine to do this. I want to avoid a lot of if-then else statements. I wrote a math expression parser known as exp4j. That was released under the Apache license. You can find it here. Also take a look at Dijkstra's two-stack algorithm. So you could go and find code that did it. It's not built into the language. And again, that's too bad. There are other reasons to use the wrapper classes, just besides converting strings to integers. Let's just type double with a capital D. That's how you differentiate the wrapper classes from the primitive data types. Everything in Java that is an uppercase letter is a class, or should be if you're giving your own names to them. You should never give a class a lowercase letter, and you should never give a method or a variable name an uppercase letter unless it's a const, a final, in which case you can give it all caps. But anyways, double dot, and take a look at all the different things. You can convert it to a string. Okay. I'm kind of confused by value of string. How is that different from parsing? I don't know. I don't know what the difference between value of and parsing is. That'd be another question to Google up and check Stack Overflow. But anyways, check these out. The maximum value and the minimum value. Suppose you had a number and you weren't sure that it would fit into an int. You were afraid that if you tried to store it into an int, it would be overflow and you would get a bad value. Let's test this. Let's create a long. I'm just going to call it capital L for long. Is equal to, I'm going to make it a small value this time. If L is greater than integer dot max value, all with caps, and there's an underscore in there, then print system.out.println L before the quotes, L plus beginning quotes fits in an int. And then add another else that prints the opposite. Else system.out.println L plus open quote does not fit into an int, or is too large for an int. Its magnitude is too large. What if it was a negative number? But anyways, I'm not sure if this counts. This would not. So instead of does not fit, let's say L is too large for an int, because this isn't taking into account negative numbers. So L is too large for an int. Now, definitely a 31 is not too large to fit into an int. What? Oh, not L greater than. It should be L less than or equal, right? The only way this thing would have printed that it's too large for an int is if it wasn't too large. So we had to make a correction there. If L less than or equal to integer dot max value. And 31 does in fact fit into an int. What if we changed it to a huge number? Blah, 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 and then a capital L, like that, to make it a long. Just type in something larger than 2 billion, and then append it with an L. Then when you run it, it says it's too large for an int. So that works. Let's find out what that max value is. Underneath all that stuff, let's just system.out.println integer.max underscore value is, followed by a plus sign, followed by integer dot max underscore value, like that. All on one line is fine. Go ahead and run it. It ought to be a little bit bigger than 2 billion. 2.1 billion.
If I try to assign the max integer value plus 1 to the long, it won't accept it?
If you did it into a long, it'd be fine, because longs are so much larger. I don't know. Have you just tried that?
I just tried it.
I think what it's doing is that since both of these, okay, you're gonna have to make that suffix it with an L before that'll work.
Right?
Right there where your cursor is.
Right.
Just put a capital L there. But that's a good question. Let's add one to integer.max value while printing it out. I'm just going to copy that print line statement. This is just kind of exploring. I'm thinking that it's going to do integer math, and even though these things would conceivably fit into a long, the fact that they're both that it is an integer right now means that it's going to corrupt the value. It's going to go negative. Oh, look at that. Nope. Make a liar out of me. Oh, all it... Oh, I forget. Put parentheses around integer.max value plus 1. Instead, it just did concatenation. All right, so you see that we were at max value, but then as soon as you add 1 to it, it does data overflow, it gets corrupted, it can't fit in all the bits. So if you try to do this, long, wait, we already have L defined. L is equal to integer dot max underscore value plus 1. You'd think that since L is a long, that you wouldn't get data corruption, but you still will. Oh, well, I didn't print L out, so I can't prove it. System.out.print, and then we're going to have to stop here. System.out.println L. It should print out our negative number. How would we fix that? We need one of these to be a long. If I just made it plus 1L, that'd be a long. And why? Because the way Java works is if you have two dissimilar types as operands of a math operator, it converts them both to the higher type. So this integer would get converted to a long, and then it does good math. All right, let's make a Dropbox for ourselves.
Are the numbers consistent whenever they go down, whenever you exceed the threshold for like the max number?
Well, it flips to being negative, and then as you start adding one to them, they become less and less and less negative. So, like if we did,
Is that ever used? Like, can you still predict what it's going to do?
well, you can predict it because it's equal to min underscore value. If we printed out min underscore value, max value plus 1 is equal to min value because it wraps around.
Okay. Is
As
it
to
ever
what the use for that would be, I'm not sure,
Okay.
but you could.